Before we write any code, let's build a mental model of how voice agents actually work. And by the end of this lesson, you'll understand which components make up a real-time voice agent, how they interact, and why latency is such a big deal. Throughout this workshop, you'll build a production quality voice assistant. It listens to callers in real time through LiveKit's WebRTC infrastructure. It streams speech to text, runs responses through an LLM, and converts them back to speech with text to speech. You'll add interruption handling using voice activity detection and semantic turn detection. And you'll wire up tool calls, conversation escalation, and metric collection. Every voice agent follows the same high-level pipeline. There are 4 core components. Voice activity detection determines when the human is speaking. Without it, your agent wastes money processing silence and might interrupt the user mid-sentence. Speech to text transcribes audio into tokens the LLM can understand. You'll want to choose models that support your target languages and accents. The large language model generates the reply. Prompts, planning, and tool integrations all live here. And text-to-speech converts the LLM response into audio that feels natural and on-brand. Supporting components like background voice cancellation, noise suppression, and end-of-turn detectors help the agent behave like a good conversational partner. And you'll add several of these throughout the workshop. Now, the cascaded pipeline, VAD to STT to LLM to TTS, shown here is currently the most popular approach, but there is an alternative, and that is to use speech-to-speech or real-time models that can process audio directly without explicit transcription. Now, that's not going to be covered here in this workshop, but look out for more videos on that subject coming very soon. Now, humans expect conversational latency under 500 milliseconds. Every component in the pipeline adds delay. VAD is the fastest at 15 to 30 milliseconds. STT takes 200 to 600 milliseconds. LLMs range from 100 milliseconds to a full second. TTS adds another 100 to 300 milliseconds. And so these all add up. And so you could be looking at anywhere from 400 milliseconds to 2 seconds total. Hey, how's it going? Good. How are you? I'm good. Just got back from lunch. What did you have? A burrito. Was it good? Yeah, it was pretty good. I love burritos. Cool. Anything else you'd like to talk about? You know what? I gotta go. That felt painful, right? Each 2-second delay adds up fast. In a real conversation, you'd probably give up after the second or third pause. Your users will do the same thing. Low latency agents keep pipelines streaming and parallel. They avoid blocking I/O, and they carefully choose providers that balance quality with speed. And you'll learn techniques for shaving off those milliseconds in later lessons. A real-time voice has different networking needs than text. Let's compare the options. HTTP over TCP is great for text request responses, but it has a problem for live audio. You see, TCP guarantees that packets arrive in order. If one packet gets lost, everything behind it has to wait until that packet is resent and received. That's called head-of-line blocking. For a web page, that's fine. For live speech, a 200 millisecond pause while waiting for a retransmit on a single packet ruins the entire experience. The other option is WebSockets. WebSockets are persistent and bidirectional, but they're still blocked by TCP retransmits under poor networking conditions. But then we have WebRTC over UDP, and which was designed for media. UDP doesn't guarantee packet order or delivery, which sounds bad until you realize that for live audio, skipping a lost packet is actually better than waiting for it. WebRTC builds smart handling on top of UDP. It uses Opus, a codec optimized for speech that compresses audio efficiency. Each packet carries a timestamp, so the receiver knows exactly when to play it. A jitter buffer smooths out timing variations when packets arrive at uneven intervals. And an adaptive bitrate adjusts audio quality on the fly based on network conditions. Now, all of this adds up to low latency even when the network isn't cooperating. So in practice, WebRTC lets your agent deliver first audio faster and stay responsive during packet loss and jitter. This workshop uses LiveKit's WebRTC infrastructure throughout. So let's set up a project. We're going to open up our terminal and initiate a new project using UV. So the -- bear flag, it creates a minimal project without any boilerplate files. Next, we're going to install some dependencies. So UV add LiveKit agents, Solero, and turn detector. And it's good to note here, we're using LiveKit agents version 1.3. And then LiveKit plugins noise cancellation, and then python.env. So this installs the LiveKit agents SDK with Solero VAD and turn detection, noise cancellation plugin, and the python.env package for environment variables. Next, we need to go grab our API credentials from our LiveKit cloud dashboard. If you haven't created one yet, it's completely free. There's a link in the video description. So here on the dashboard, I'm going to go down to settings, API keys, and then I'm going to create a new key for this demo. And I'll just name this voice agent demo. And let's generate a new key. So these are the things that you're going to need: the WebSocket URL, the API key, and the API secret. And to make things easier, you can just copy and paste these environment variables right here. And of course, I'm going to delete my API key, so this one is not going to work for you. But again, it's completely free. Just go ahead and set one up for yourself. So let's go back to the editor. And we'll create a new .env file, and you'll go ahead and paste in those credentials. Again, we have our LiveKit URL, our LiveKit API key, and our LiveKit API secret. So make sure that you save that file, and then you can close it. And also make sure that the .env file is in your project directory. Okay, let's go ahead and create another file, again, in our project directory here. We're going to call it agent.py. And so this is going to be our starter agent. And I'm going to paste in some code here, and we'll walk through it. Now, again, if you're following along in the written guide, you can copy and paste the code as well from there. So at the top here, we've got our imports from the LiveKit agents SDK. The agent class defines your agent's behavior. The agent server handles dispatching sessions, and the agent session configures the voice pipeline. We have a job context here, which provides information about the current job when a particular participant joins. And then in our session start, we have the room IO, which provides options for configuring audio input and output. So in the agent session here, you can see we're configuring our STT, LLM, and TTS, and also our VAD. And just up here, we have our basic instructions for this agent. You are a helpful VoiceAI agent. So very simple starter agent here for you. So let's go ahead and get this agent running and see what it does. So again, be sure that you have saved this file. Let's open up our terminal. So the first thing that we need to do is download the required model files like the Solero VAD model. Now we only have to do this the very first time. So UV run agent.py and then download files. Now let's run the agent. So we can just do the same thing except remove the download file. So UV run agent and then console. So we're going to actually run this right here in the console. Hello.
Hello, how can I assist you today?
Oh, great. What can you assist me with?
I can help with a variety of tasks, such as answering questions, providing information, assisting with writing and editing, helping with learning new topics, generating ideas, offering recommendations, and much more. What do you need?
Very helpful. Thank you. Thank you very much. We'll talk to you again later. Bye-bye. Very helpful assistant. Very nice. Now to stop your agent from running, just press Control-C. Now, if you're having any issues here in the console, it could be your input or output device selection. So you can actually add some extra flags there to select your input device. List devices, lists all of the devices that you have on your machine. And then you can use the device ID to set the input and output devices using the input device and output device flag. Now, voice agents deal with messy real-world inputs. People mumble, they change their minds mid-sentence, and they ask things in ways that you never anticipated. So starting to think about how you'll test these scenarios now will save you headaches later. Now, testing and metrics, they come up later in a later lesson, but start keeping a backlog of scenarios that you want to test as features land. So think about like edge cases, different accents, background noises, and interruptions. So now you have a working voice agent and you understand the core pipeline. That VAD detects voice, STT transcribes it, the LLM generates a response, and TTS speaks it back. So in the next lesson, you'll add semantic turn detection to prevent those awkward interruptions when an agent jumps in too early.